Okay, good. Thank you. Hello again. Well, let's start with buildings. They are hot. Whether we're heating them or cooling them, they chuck heat to the city. They're like big, giant heating devices for the city. And this becomes the most immediate and direct way of climate change of the urban spaces around them. And then climate change brings more climate change. The warmer it gets, the more you need of that heat that you're chucking out. And the urban morphology and the build form of our buildings become key factors in this process. And in fact, they become key factors also in creating completely unpredictable microclimates around them, which is one of the problems in the sense that now the weather data we get in the statistics will not necessarily represent what we have on the sites that we are going to be building. And so here we come with our research agenda in the program, which we started some 6 years ago, refurbishing the city, creating symbiotic relationships between the buildings and the spaces which they form and occupy in the city. With these objectives, improve environmental conditions and quality of life in cities, achieve independence from non-renewable sources, and develop an environmentally sustainable architecture. And over this period, we have initiated some 400 projects in 140 cities, 50 different countries, about 1/3 of them in the UK, in London. Our program has started back in the 70s, in fact, very small. I was one of the first students. There was only 3 of us on that first year. But now we start with a much bigger group, some 50 or 60 students, including the returning MArchs. And central to the work is our workspace, the studio that we have on 16 Morwell Street in the first floor. I'll give you directions in a minute, where we have our tutorials, we have our reviews, the students work in teams or individually, and in fact, we also hold our lecture series there. And we start the learning process with learning how to observe how a space is used, what kind of environmental conditions do they provide, and in which way do these environmental conditions affect occupants? If the sun patch moves, do I wish to follow it or avoid it? And can I do either of these? And is the sun patch dependent on time? It is. Is it dependent on weather? It is. And is it dependent on the form of the building, the plan and section? It is too. So how do these affect? And we take measurements as a way of finding out, as a diagnostic, but also as a means of calibrating software. First, we have to analyze measurements. Measurements give us a sense of time, which otherwise we don't necessarily have. How do conditions change over time? And how do they change across different spaces? And how do these results compare to benchmarks? Like here we have traced the thermal comfort zone for the occupants within a certain range of temperatures, and you can compare this to the outdoor air temperature and to the temperatures in different spaces. And what creates the fluctuations, whether they come from the outside or the inside? So interpreting this kind of data becomes a very interesting and useful task. And then being able to use this data to calibrate software is great, because then the software gives us the capability for modeling spaces and simulating alternatives. What if I change this? What if I change that? What effect will it have on, for example, energy use, on, for example, how occupants feel in the spaces? And therefore, as a result, come up with strategies from an existing situation to a proposed improvement. The program, like the other MSc and the MArch programs in the school, is structured in two phases. Phase one, in our case, is joint between the MSc and the MArch, so they work together in teams, they're doing the same things. This is a stage that lasts 2 terms, from October to March, and each student will have participated in 2 team projects and then will have produced 2 research papers individually. And then we have phase 2, which for the MSc will extend from April to September with individual dissertation projects, and then similarly for the MArch with a different duration, their extension from April to June and then September to February with, again, individual dissertation projects. So just to illustrate the process of what we do and how we do things, I'll start with inputs from lectures, have lectures at different sort of scales, from general processes that identify issues of environmental design to the more architectural aspects of them, and then into the urban realm. So lectures bringing in new concepts, and then workshops introducing the instrumentation that we will use on field studies, and then the computational tools. Fairly extensive. We spend a whole day, a week, every week for 2 terms on the tools. And then the application of the concepts and the tools into the practice that we have, into our projects. And London becomes the laboratory for our projects in the first 2 terms, because it is there and we need it to be there. We need buildings to be there that we can enter, we can access, where we can observe, where we can take the measurements. And so London's urban morphology, built form, the materiality, the occupancy of buildings become of interest to us on these projects. And in the first term, that period that is just starting this week until mid of December, we have what can buildings tell us? And well, we will offer a series of buildings to be studied, to be visited, and some to be revisited. Buildings like, for example, this one, sadly, now under demolition. Many of you will know this as a very famous building. It also has the best solar access potential of all buildings in London. It's just facing south downwards like that. And on a sunny day, you have a very good penetration of sunshine through there. I've studied this over 2 years. And we look at the site, at the potential and constraints that it offered to the architects as the building was built, and then also to the wider potential and constraints perhaps it offers to us today. Now here, the architects ingeniously created this combination of interlocking spaces, quite complex, which the students felt inclined to try to deconstruct and analyze, appreciating both the ingenuity and also the environmental issues that this entailed because of the ways in which it exposed the building both to the outside without protection and also in terms of privacy, which it started lacking. You will see from these images a little bit of these issues. You'll see how the occupants felt inclined to try to protect from perhaps intrusion and issues of privacy to too much sun or too much cold as measurements of temperature on a fairly mild set of days in end October a few years ago, and the indoor temperature against that comfort zone, how it fluctuates, what causes the fluctuations, why are they different with that of the outside, and how about this other flat where the fluctuations are very different. yet again. And how on earth, when the outdoor temperature drops to something like 5 degrees centigrade, do we have 30 degrees inside? These are interesting questions that we are very keen to be able to study. And the measurements then tell us about the differentiation of conditions of temperature as well as of illuminance inside these rooms. And the effect that, as I was mentioning before, the room shape perhaps, or other factors have on this differentiation. And the modeling allows us to ask these questions of how could things be different. And were the differences in the temperatures between these two flats due to different levels of heat gain inside? For example, relating to occupancy, one was occupied by a larger household than the other. And did some of the problems that I alluded to earlier have to do with the fact that the building suffered from lack of insulation and then exposure through these streets in the sky that gave access to the flats? I think this is not a slide I wanted to keep, so I passed very quickly because otherwise it would take me some time to explain, but suffice to say that this was a series of simulations with the aim of investigating possible improvements, which are summarized here. And so then it is in this way that that first project finishes with certain findings which then become the basis for our second term design projects. So the buildings told us something, now what can we tell back? What can we give back with our own creative process? And so the students have to create a design brief based on the findings of the first term project, find a site, and then we would prefer to do the simulation work before we have a design so that it helps with form generation. So we can then optimize the form, add components that the occupants can use, and finalize the design. I'm just going through this very, very quickly. And so that sort of concludes the first stage of the training process over the 2 terms, which provides the background now for our students to be able to look at individual dissertation projects. Much of this work leads to publishable material, and in fact, we are very keen to have publications. We have published 5 books in issue this year, which became very popular with something between 20 and 30,000 hits. And now coming to the dissertation projects for the MSc and the MArch. Here, it's not just a quantification, but we pose ourselves a serious question of what makes a good environment. Good, meaning good perhaps in terms of quantities, in terms of the kind of numbers that we measure as thermal and visual comfort, but good also in terms of other qualities. What makes a good environment outdoors? I mean, what makes these people appear to be so happily engaged in what they're doing without a table or a chair on which to eat? And what makes a good environment indoors? What makes a good environment in between outdoors and indoors? And who a good environment for? Somebody who stays, somebody who's passing by, somebody who's visiting, and somebody else than human. So these are key questions which we know we cannot answer as just a quantity. So a good environment then for us is a combination of measurable and unmeasurable factors. It's a combination of performance and atmosphere. And to start on this process, often we start with some small projects. I'll show you very quickly some that we did. This one was took place some 10 years ago when we teamed up with one of the intermediate units, I think intermediate unit 4, with Mark Hamill as the unit master, and on the invitation of the village of Pankeze in Ghana, went there to build an outdoor room for the village's primary school, which you see here. That whetted the appetite of students, so as they saw, as the next coming in students saw that structure, which was not very efficient environmentally, it allowed too much sun to come in, then they thought they could do better. And that was the next one, a shelter for archaeologists. And then this didn't have moving parts, although it was quite good. Then moving parts, and then a white tent inspired from the black tent of nomads. It's like these were designed and built at Hook Park, and then we carried them wherever we could. Twice on Santorini, the island of Santorini in Greece, and once, the last one in Sharjah at the American University campus. This one is the moving one. The students thought that it can't be fixed, it shouldn't be fixed. It's an urban furniture, it's a seat for outdoors. And you can fix how it protects you from the sun and how much airflow you want to allow in there. It's the pieces that made up this white tent of the black tent. And back to the dissertation project, a key factor, a key concept is what we do with the urban block. And lots of our MSc and MArch dissertation projects carry this preoccupation in a number of different cities around the world, both north and south of the equator. Here we see a piece of the urban tissue of Athens in Greece, and a section across one typical block with temperatures of surfaces and the air being measured in different parts. And we can see essentially that, that there are large differences which form, differences and conditions which are not immediately predictable, which you would not find in the weather data from the med stations, and which are the result of the morphological characteristics of the street canyons and of the build forms and the courtyards that are formed on the inside of the urban block. Studying this with simulations, if you see the central block as being our reference, and then the surrounding blocks represent the effect of the immediate effect of the rest of the city, we can then start with the base case of the urban block as is, and then start asking questions about whether more vegetation or lifting the buildings on pilotis would make a difference, and in which direction. But more than that, I think walking in the city becomes very important in order to appreciate. Sorry, I've forgotten this side of the room and might have been turning my back to you. It was empty in the morning. There was just Brett there, and I wasn't looking at him, just in case. So now I shall be looking at you two from time to time. In any case, I should be finishing soon, I think. So I was telling you about walking in the city and looking at the way in which these microclimates are formed and experiencing them, and then seeing how one might study them. And this illustrates that, and then a section is identified through which a group has walked. And you see the numbers there, and we'll see the appreciation of these spots from the group. as being, the same or warmer or cooler as they move around from one point to the other, and then getting quite surprised and then trying to interpret how did this happen, what causes that, which is quite interesting. And then that finding to be able to bring into a new design in the case where perhaps an empty urban block becomes available, as is the case here. More often than not, an empty urban block is not available. And then the question, which I think a very important and fascinating one, especially for cities like Athens, which were built very quickly in the 1950s and 60s, and are now suffering from this stock becoming older and being very poor environmentally. So what can we do for them? And whether we can do things, for example, on the roofs, that are able to unite the different buildings in useful ways. I mean, in reality, the block has many buildings, and each building has many apartments, and each apartment may belong to different families. So bringing them together is not easy, but is very worthwhile. And we have similar projects with the different morphologies and typologies of other cities. Here we see the urban blocks in Buenos Aires, Argentina. And the same principles of environmental design we bring to bear on the form generation of the building form. A passive zone is a depth of a building to which daylight and fresh air can come in from the outside. Dimensionally, it varies quite a lot. And that has to do with the form of the plan and with the section. And so everything environmental that we do is a fundamental architectural principle or question. Deciding what the passive zone is already breaks a block, an imaginary block that could have been the building. And then other criteria can come in, a combination of architectural and environmental criteria, such as permeability, connectivity, which start shaping the block, the building, in non-arbitrary ways. The interface with the outdoor. Here, as you will have seen, the questions are about a climate that is Mediterranean and about a function, a building function that is of the work environment. And the question is being asked here about the interface with the outdoor, and it's being asked in the natural sort of sense, not in the exclusive sense of the outdoor, I don't want it, I close my box, air conditioned. Here it's an open question, and interaction with the outdoor is desirable. There are times when, in fact, the outdoor can be more pleasant than what we call indoor. And so that interface becomes critical, and what we call here dynamic coupling, i.e. the ability of blocking it or opening it, becomes a key factor in the composition and in the final result of the form, which we see here now, the indoor, the outdoor, and the in-between, and how the relationship may vary, thereby allowing an extension of the indoor outwards or not. And we're very much into a new architecture for the tropics. And there, the traditional architecture, the vernacular, gives some very good starting points in the very good design of the roof to provide shading, in the permeability to airflow, to counteract the effects of humidity. And these principles can be extracted quite easily and brought in a fresh way, original way, into contemporary buildings. And we have several projects, both at the MSc and at the MArch dissertation, inspired by these ideas. Glass is a bad trap in the tropics. It's an expensive trap as well. and its replacement with more appropriate elements and components is a source of original work that our students are involved in. And the layering of spaces, you see the outdoor there, non-glass, it's a range of screens until we get into the more protected inside. There's another application of the same principles for the design of a primary school in the tropical areas of China. As its extension to the outside through this mesh. And the roof, obviously, in this case, becomes critical, not just as a shading device, but also as a regulator of daylight, since the depth of the building now will exceed what I called the passive zone a few minutes ago. It's another project for a research center in the Amazonia region of Brazil. This is, we are very equatorial now. The sun is overhead, and buildings there will take this roof form, a big roof, but open on the sides. And the boats, same design. I think this is the final project. The economic crisis in Spain has brought construction to a halt. And the question of what happens to all these buildings that have been abandoned, incomplete, is a crucial question, given that I think something like 80,000 households have found themselves homeless altogether and completely unable to pay for their mortgage. And this was a project that was completed in March this year, which was nominated by the school for the RIBA President's Award for Research, and has actually been shortlisted by the RIBA. The results, I think, are due to be announced sometime very soon. I was telling you about publications. So these are the 5 books that we produced in issue. VAA is a big publisher in issue, very popular publisher, there you can see. And as I said, ours, especially this one, our showcase for last year's MArch, with 30,000 hits. I couldn't believe it. But we're also interested to publish more broadly. We have an article in there with student projects in this book, Green Design, edited by Ken Young, and also in this special issue of AD on experimental green strategies. And I want to tell you something about PLE, the Passive and Low Energy Architecture, an expert group which I helped found some 30 years ago. This book dates from 1983. And PLE, which continues today and has my colleague Paula Cadima as the president, is now on its 30th international conference. The next one is coming up in December in Ahmedabad, in India, on this topic of sustainable habitat for developing societies. We have contributed half a dozen research papers to that conference, but perhaps more importantly, we're also contributing a selection of projects done by our Indian students of the last few years. So we made a selection of 12 dissertation projects by our alumni from India, which will be exhibited at the conference and presented also with papers. I'm just showing you 4 of those. I couldn't fit all of them on this slide. So now, I'm finishing. I need to tell you about tomorrow, and I need to tell that only to those of you who have come to join the SED program. I think you are this group here. So tomorrow is the day when our new students are presenting. They're introducing themselves. Your introduction should be with 6 to 10 slides. You already know about this because we've exchanged emails. It's showing 6 to 10 slides of projects that you like, of your own. in 6 minutes. I will tell you why there is time limit. The first 6 are Ruchi, Ali, Ruchi. Here? Yes, Ali? Yes? Sorry, I need glasses. Amir? Anil? Yeah. And April? There somewhere. And Gustavo? Well, you're all there. Good. Because you need to be there first at 10 o'clock to set up. And this is where we are. So 16 Morwell Street. And then entry up, first floor landing, left, and this is the SED studio. And I think all of the names that are listed there, I think all of the people out there are here already. So now, the reason why I can see my colleagues waiting there. The reason why we have to shorten the presentations is because at the end of those presentations, then we will announce a design brief for a design charrette that will occupy you for the rest of the weekend with presentation on Monday afternoon. Okay. And then we will announce the projects for this term on Wednesday. We have a program guide which describes the program in great detail, which I will distribute tomorrow. And the timetable for the term with weekly events, which we will also distribute soon. So in the meantime, if you have any questions, email me. Thank you.